Hello everyone and welcome back to another video. Today we're going to be starting the A2 slope outcome. Four key ideas that we're going to talk about today is understanding slope as rise over run, as a rate of change. We're going to talk about the relation of slope to angle of elevation, and we're going to solve a few contextual problems. So the first thing that we have to do is define what is slope. We actually see slope all around us in our everyday lives. We can look at the driveway of your house, the escalator at the mall, and at the ski hill as well. So can you think of any other places where you might be able to see slope in your everyday lives? So a few examples that we typically see day to day will be ramps, roadways, roofs, and even flight paths. So we'll talk a little bit more about slope in a contextual situation later on in this section. So when we think about slope, we often think about how steep something is, and that's absolutely correct. But in mathematics, we typically define slope as the ratio between its rise and run. So in other words, we are trying to describe both the direction and the steepness of a line. Now let's talk about what rise and run are. The rise of a line measures the vertical change between 2 points, so otherwise known as the change in y. And then the run of a line measures the horizontal change between 2 points, otherwise known as the change in x. So if we look at the example down here, we can see that the rise talks about your change in y. So we're seeing how many units we're going to go up from this point to this point. So we're counting up, and we can see here that we're going up 1, 2, 3, 4, 5 units. So we can state that the rise in this example would be equal to 5 units. So we are going to have a positive 5 because we are counting up. On the other hand, if we think about the change in your run, or rather your change in your x, we can see that we are looking at 1, 2, 3, 4, 5, 6 units towards the right. Now if we're moving towards the right, it means that we are moving in a positive direction, and we'll see later on that when we discuss slope, we typically talk about it going from left to right. So for us, if we're looking at this formula, m is equal to rise over run. We use m as our variable for slope. And if we were to plug in our rise and run into this formula, we get m is equal to 5 over 6. So in order to interpret what this means is we would say that since our slope is 5 over 6, it means that for every 5 units that we move up, we move 6 units to the right. Now we're going to explore 4 types of slope in this outcome. The first one being a positive slope. So we can see that when we're moving from left to right, so really important, we're moving left to right along your x-axis, your line is going to move upwards. So we can see here, as we're moving left to right, your line is going up. On the other hand, if we're looking at a negative slope, when we're moving from left to right again, your line is going to move downwards. So if we're going up, it's positive. If we're going down, it's going to be negative. So remember, just keep in mind that we are moving from left to right. Now the two that will be a little bit tricky to differentiate will be having a zero slope and an undefined slope. So let's talk about what the difference is between the two. So in moving from left to right, for a zero slope, your line actually does not move up or down. It just remains a flat line. If we're looking at an undefined slope, when we're moving from left to right, your slope is actually what we call an undefined slope. Now a line having a slope of 0 would actually just be a horizontal line, so we can go ahead and jot that down really quickly. So having a 0 slope means we are looking at a horizontal line. And then having an undefined slope means that we have a vertical line. Now a couple questions to consider and maybe pause the video to think about it first before we continue on. We need to ask ourselves, why does a slope of 0 make a flat line, and why does a vertical line have an undefined slope? To answer these questions, we need to go back to our horizontal line here, and we can see that going from left to right, it does not move up or down. So in this case, we can actually say that there is no rise. There is no change in your y values. So we're not moving up and we're not moving down, so there's no rise. Which means for us that 0 rise divided by any number is just going to be 0. So we always have a 0 slope. Now on the other hand, if we're looking at a line with an undefined slope, and we're going to look at the one on the right here, if we're looking at a vertical line, we actually have no change in x values. So if we're looking left to right, it doesn't move left to right at all, so there is actually no run. So we can state that for this example, there is no run. Which means if we plug it into our slope formula, any number, and we don't know what the rise could be, it could be 1,000, it could be 1, it could be 1.5, any number divided by 0 will give us an undefined slope. Okay, so once again, if we have no rise, we're going to have a 0 slope. If we have no run, we will have an undefined slope. So you might be asking yourself, why do we call it an undefined slope? Why can't we divide by 0? Well, if we think about it this way, we've known for a while that there's a relationship between dividing and multiplying. If we think about the example 20 divided by 4 is equal to 5, there's a relationship here between the 4 and the 5, showing that if I were to multiply these two together, we'll get 20. And we can see that if we do that, then that checks out. Now on the other hand, let's say I take 10 and I'm going to divide that by 0, and it's going to give me some number. So 10 divided by 0, we will say that it should be equal to some number if it's possible. Now once again, looking at my relationship between these two values, this implies that 0 times x should be equal to 10. Well, we're going to ask ourselves, what times 0 will equal 10? And the answer is x is undefined. There is nothing that when you multiply 0 with x that will give us 10. So that's why anything divided by 0 is what we call an undefined value. So we're not able to actually give a number that will make that equation true. So that's why we call it undefined. So the next thing that we're going to do is we're going to look at line segments and try to figure out what their slopes are. We can identify the slopes of line segments by counting the number of units that it moves up and down and to the right. Now just again, another quick reminder that we always think about these as moving from left to right. And additionally, keep in mind the scale that's being used for each variable. Now what I mean by keeping in mind the scale is we can see that each square here is 1 unit. In later examples, you might see that each square might actually represent 10 units or 100 units and so on. Let's quickly work through a couple of examples together. So in this example, we're going to try to figure out what our change in y is as we move from A to B. So we're going to try to go up from here until we're level with your B point here. So let's see how many units it takes for us to get to a level point. So we're going to go up 1, 2, 3, 4, 5, 6. So our rise in this case is equal to a positive 6. And your run, let's start from here, and we're going to move all the way over to where the B point is. So we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if we plug this into our slope formula, we get m is equal to rise over run, which means that we have 6 over 10. Now something that we need to keep in mind is whenever we're working with slope, we want to reduce the fractions to simplest form. So I can take the top number and the bottom number and divide them both by 2. So 6 divided by 2 gives me a 3, and on the bottom 10 divided by 2 gives me a 5. So we are really just factoring out the greatest common factor and simplifying. So we have 3 over 5. So if we were to use the slope of 3 over 5 to figure out what my other point is on this line, we can say that we're going up 3 and then over 5 to the right. If we were to do it one more time, up 3, 5 to the right, we'd see that we'd arrive at point B. So we know that we've done this question correctly. In this next example, we're going to go ahead and take a look again at our rise compared to our run. So we're going to try to go from C to D. Remember, we're moving from left to right. So left to right, our slope is going down. So we can see that we are going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. So our rise in this case is going to be equal to negative 10. Remember, it's a negative because we are moving down from left to right. If we're looking at the run, we are moving across 5 units to the right. So plugging these into our slope formula, m is equal to rise over run, we can quickly see that we're going to end up with a negative 10 over 6. And then we can simplify this to negative 5 over 3. Now I'd like for you to take a couple minutes to try to figure out what the slope is of these two examples. You can pause the video and resume once you're ready to continue. So we can see that moving from this point here to this point, moving from left to right, we are going down 1 and then 3 to the right, which means that my slope is negative 1 over 3. In this example, going from left to right, we're moving up 3 and then 1 to the right, which means that your slope is 3 over 1, or just 3. Alright, so on this page here we have a few practice problems. Go ahead and pause the video so you can try each one of these out, and then once you are done, you can resume the video. So if we take a look at this first problem, we're going to look at the rise. And we can see here that going from left to right, we are moving up 9 units, so our rise is equal to 9. And then our run, as we're moving from left to right, is going to be 6. So our run is 6. We know that slope is equal to rise over run. So we get 9 over 6. We can reduce this to lowest terms by dividing both the top and the bottom by 3, and we end up with slope is equal to 3 over 2. And we can check our answer again by counting up 3 units and going 2 to the right. We end up with a point. We go up 3, 2 to the right, and we have a point, and we go up 3 and 2 to the right, and we end up going from E all the way to F. For the second problem here, going from left to right, we can see that we are looking at a negative slope. So we are going to go down, first of all, 3 units. So our rise is equal to negative 3. And then our run, going from left to right, we see that we're going 4 over here, and then we're moving 5 in addition. So our rise is negative 3, and our run is a positive 9. So we can write our slope as negative 3 over 9, going to lowest terms, negative 1 over 3. So this just means that for every 1 unit that we're moving down, we're moving 3 to the right, and you can see we have a point here. Go down, 3 to the right, 1 down, 3 to the right, and we can see that we have a straight line going from G to H. Now looking at line A, we can see here that we're moving up 2, 1 to the right, so our slope is just 2 over 1, or 2. For line B, we can see that going from left to right, we're going up 1, and then 2 to the right, so our slope for B is going to be 1 over 2. For our examples here, going from C to D, we're moving up 5 units, and then we're moving 4 to the right, so our slope will be 5 over 4. For the second example here, we can see, or from A to B rather, we're going up 1 and then 4 to the right. So our slope is 1 over 4. And last but not least, for E to F, we're going down 3 and then we're moving 4 to the right. So negative 3 over 4 is our slope. So I've kind of spoiled this on the previous page, but again, we do need to kind of point this out. If we're looking at all the different points on a line, we want to be able to figure out, will the slope between any 2 points on the same line be exactly the same? So the first thing we're going to do is calculate the slope of line segment D to E. So D to E, we know is going to be right here. We can see that my slope, in this case, we're going to be going up, and we can see that the slope, or rather the scale of each square is 2. So going up halfway is just 1. So we're going up 1 and then we're moving 2 to the right. So your slope is just 1 over 2. Now can we predict the slope of line segment E to F? And we know that E to F is right here. And yes, the rise over run is the same. Alright, so if we're looking at rise over run, we're going up 1 and then 2 to the right. And last but not least, can you predict the line or the slope of line segment A to F? So A to F is going to be the entire line segment, really. And if we were to figure out what A to F was, we would see that really quickly. And if we were to figure out the slope of A to F, starting from here, this is 3. We're going to move up all the way until 8. So this would be your rise of 5, and then a run of 10. So we can see that our rise over run is the same as DE and EF. So the slope of A to F is really just 1 over 2. Now another line segment with the same slope as AF, we can really just look at any 2 points in the line. We've got AC, AD, we have BD, BE, etc. So we've got a lot of options for this question here. So the most important thing to realize is that any straight line, if you were to pick any 2 points on a straight line, the slope will always be the same. Now in a more contextual situation, we can apply that to maybe something such as stairs. Now we can see in this case that the rise for each step is going to be 8 inches, and then the run is going to be 10 inches. Now what does this mean for us? Well, it just means that all of your steps are going to be consistently sized. Now, have you ever gone up or down the stairs and you realize you tripped because you expected perhaps the steps to be a little bit higher or a little bit further? Well, that just meant that you went up some inconsistently sized stairs. Your body was expecting one thing and out came another thing. So we're going to apply this to an example down below. So Robert built some stairs so his puppy could get on the bed by herself. The stairs have a height of 18 inches and a horizontal length of 22 inches. So we want to figure out what is the slope of the stairs. Well, remember, to calculate the slope, we need to figure out the rise and the run. Well, height is going to be our change in y, so that's going to be my rise. And the run, our horizontal length of 22 inches, will be that run there. So our slope is equal to rise over run, which is equal to 18 over 22. And we can simplify this by dividing both the top and the bottom by 2. So we get 9 over 11. So the slope of each step will also be 9 over 11. Because each step will have the same slope as the stairs. So here on the next two slides, you'll find a few practice problems that you can try out. So you're going to be looking at the slope of each line segment here, and then answering some questions about slope. There are also a couple of questions here asking you about the undefined slope and if a linear relation has a slope of 0. Pause now and try these out, and I will show the answer key on the next page. When you're ready, go ahead and unpause, and we'll continue the lesson. The next thing that we're going to do is look at slope in context. So that means we're going to look at slope in some real life situations where we can apply our knowledge of what slope is. The first question asks, Charlene is working on a project in her art metal class. She wants to make a brass cookbook holder like the one in the diagram. She does not have a protractor to measure the angle, but the diagram is drawn on graph paper. What is the slope of the cookbook holder? So the first thing we can do here is we notice that there is a grid behind that cookbook, and we can use this grid to help us figure out exactly what the slope will be. So step number 1 is we're going to figure out what the two endpoints are. The first one is going to be down here where the edge of the book is being held, and the one other point is going to be here at the top. What we're going to try to figure out is what the rise over the run is. So counting up our square units, we're looking up here, we're going up 1, 2, 3, 4, 5, and 6 units up. So that means that I have a rise of 6. And then when I count my units moving towards the right, we notice that we have a run of 4. So using our slope formula, m is equal to rise over run. We can fill it in with our two values. 6 divided by 4. And we can simplify this by dividing both the top and the bottom number by 2, and we end up with 3 over 2 as our slope. So what does our answer tell us about the relationship between the vertical change and the horizontal change of the cookbook holder? So there's a couple of different ways that we can explore the relationship. The quickest way is to interpret our slope as telling us that for every 3 units, we move up, we move 2 units to the right. Now we're going to compare some of the results that some students have found. It says that Andy says the slope is 3 over 2. Amanda uses her calculator and gets the answer 1.5. Jennifer says the slope is 6 to 4. Explain who is correct. So what we're going to notice here is that 3 over 2 and 1.5 are actually the same answer, because if I take 3 and I divide it by 2, I actually end up with 1.5. Meanwhile, Jennifer says that the slope is 6 to 4. If we convert 6 to 4 into a fraction, 6 to 4 can actually be simplified to 3 to 2. Well, that means, since these are both 3 to 2, then that means that Jennifer also has the same answer as Andy. So Andy, Amanda, and Jennifer all have the same answer. So Andy, Amanda, and Jennifer are all correct because 3 over 2 is equal to 1.5, which is also equal to, and maybe I should write the original, which is the same thing as 6 to 4. For this next example, it says that a panel of glass needs to be replaced on the escalator shown. Leanne places the order with the glass company, but she needs to tell them the slope. So what is the slope of the glass? We're going to identify first the rise and the run of our slope. So here we can see that 20 feet going vertically will be our rise. So that means that the 35 feet going horizontally will be the run. So our slope, once again, is equal to rise over run. And that's going to be the same thing as 20 over 35. Now we want to reduce our fraction to simplest terms. So we can divide both the top and the bottom by 5, and we end up with 4 over 7. So our slope ends up being 4 over 7. This next question involves a lot of algebra, but we are still going to be using our slope formula. So Duncan and Casey are using hand trucks to move small boxes from a house to a garage. They lay a loading ramp against the house steps, which are 18 inches high. The slope of the ramp is 0.2. What is the horizontal run or distance in feet from the base of the ramp to point X? So really what we're looking for is this horizontal distance from the edge of the ramp all the way up until point X. We know already that the steps are going to be 18 inches high. So that's going to be this right here. That's going to be 18 inches. And we know since we're working with a vertical distance, that will be the run. We know the slope of the ramp is equal to 0.2. So we're going to use our slope formula to help us out. So starting off with our formula, m is equal to rise over run. We're going to go ahead and plug in everything that we know. And I just realized here I actually accidentally wrote down run when I meant to write rise. So m is equal to 18 over your run. Or rather, let's call it x. And since we know that the slope is 0.2, we can go ahead and replace this with 0.2. So what we're going to do is we're going to solve for x. I'm going to multiply both sides here by x. And we end up with 0.2x is equal to 18. In order to solve for x, I'm going to divide both sides by 0.2. And I end up with x is equal to 90. Now we're not quite done our question yet because we were asked our distance in feet. Since we worked originally with 18 inches as our rise, this would mean that our run is 90 inches long. How do we convert inches into feet? Well, we know that for every 12 inches, it gives us 1 foot. So we can take 90 inches and divide it by 12 to figure out our number of feet. So 90 divided by 12 gives you 7.5 feet. So that will be our horizontal distance, or the run, of this ramp. In this next question, it says that Raymond is trying to figure out the measurements of his new roof. He has 2 options presented to him by the roofing company. So option A says that the roof would rise 14 inches for every 8 feet. For option B, the roof would rise 18 inches for every 12 feet. He wants the steeper roof so that rainwater would drain easier off of it. Which option should he go for? So what we're going to do is we're going to figure out exactly what the slope is for each roof. What you should take note of first is that we have inches and we also have feet, so we want to make sure that we have the same units before we start to convert or figure out what that slope is. So we need to convert, first of all, the feet into inches, just so it makes a little bit more sense for us. So 8 feet times 12 gives us 96 inches. So I'm going to go ahead and put 96 inches here. So 96 inches. Again, you want to take note of what is the rise and what is the run. Well, since something is rising 14 inches, that will automatically make that our rise, which means that 96 inches is the run. So we know that m is equal to rise over run, which will be equal to 14 over 96. And we're actually going to convert this into a decimal, just so we can really figure out which roof has the steeper value. So 14 divided by 96 gives you 0.1458. We're going to do the same thing here for the second option. The first thing that we're going to do is figure out that rise is 18, and 12 feet is the same thing as 144 inches. So we can say that m is equal to rise over run, and that's going to be the same thing as 18 over 144. Once we punch that into a calculator, we end up with 0.125. So since 0.1458 is greater than 0.125, Raymond should go, or should choose, option A. So we have figured out which roof Raymond is going to buy. Matt's backyard has been flooding, so he decides to install a drainage pipe. Matt learns that the pipe needs to drop 1/4 inch per 1 foot length. So what does that mean, that the pipe drops 1/4 inch per 1 foot length? Well, we already have the answer there, but it's just our job to kind of interpret what that means in a real life context. So it just means that for every vertical drop of 1/4 inch, the pipe runs for 1 foot. So we can kind of imagine, basically we're saying if it goes down 1/4 inch this way, it's going to be 1 foot long this way. So we can give ourselves a little quick visual here, 1/4 inch here, and then 1 foot or 12 inches going that way. So we're going to figure out what the slope of the pipe is. We know that our rise is going to be 1/4, and your run, since we've already converted 1 foot into inches, it's going to be 12. So since m is equal to rise over run, this is the same thing as 1/4 divided by 12. Now I know a lot of you guys aren't the biggest fans of multiplying or dividing fractions. We'll take a look at this and figure out what can we do with them. So we can actually rewrite this as 1/4 over 12 over 1, right? Because we know that 12 is the same thing as 12 over 1. We still have the same thing here. And what happens when we divide fractions is we're going to take the original top fraction, our numerator, so we just have 1/4, and we're going to multiply it by the reciprocal of your denominator fraction here. So the reciprocal of 12 over 1 is 1 over 12. So now we're going to multiply straight across the top. 1 times 1 gives you a 1, and 4 times 12 gives you 48. So your slope is 1 over 48. For part C, it asks for a horizontal run of 100 feet. How much lower should one end of the pipe be than the other? Express the answer in feet and inches. So we have a couple things to take note of here. Since we are looking at a horizontal run of 100 feet, we already know that the run is 100 feet. Our rise, though, is what we need to figure out. So I can put a question mark And maybe I'll actually write it as x. And we know the slope is equal to 1 over 48. And we found that out from our previous answer. So let's go ahead and use our slope formula. M is equal to rise over run. Let's plug in what we know. 1 over 48 is equal to x over 100. We can go ahead and cross multiply. So 1 times 100 gives you 100. And 48 times x gives you 48x. We're going to divide both sides here by 48. So 100. Maybe I'll go ahead and do this first. I'll say that we're going to divide both sides by 48. And we'll get rid of the 48 on that side. And let's move it up here. So you know we've got 100 over 48 is equal to x. Now what I'm going to actually do is I want to try to make the denominator on the bottom equal to 12. And I can do that simply by dividing both the top and the bottom number by 4. So this means that I have 25 over 12. Now there's a number of different ways we can solve this problem. I think this will be the simplest one, or the one that will make the most sense contextually. The units that we're working with here, we have 100 feet. So since we already used 100 feet as our unit of choice in this equation, that means that whatever answer I get ends up being in feet. So now we've got 25 over 12. Well, it's really great for us that we're working with a denominator of 12 because I can simply convert this into a mixed fraction. 25 over 12 is the same thing as 2 and 1 over 12. How did I do that? Well, how many times does 25 go into 12? Well, it can go in twice because 2 times 12 gives you 24. And what's left on top? You have 1 over 12 left over. Now, let's interpret what that means for us. We have 2 feet and 1/12 of a foot. Well, 1/12 of a foot happens to be 1 inch. So that means that your pipe should be 2 feet 1 inch lower than the other end of the pipe. So the pipe should be 2 feet 1 inch lower. So 2 feet 1 inch lower. So let's take a look at a common use of slope in everyday life. In this case, we're going to be talking about the grade of a road. The grade of a road or railway tells us its slope, and it's usually expressed as a percentage. Typically, we use this to warn motorists of a steep incline or decline. Note that whenever we're looking at a grade of a road, it's always going to be positive, even though it might be a decline. So first of all, we're going to look at what a 20% grade means. We actually already know the answer. A 20% grade really just means that the slope is 20%. How can we express this slope as a fraction? Well, we know that 20%, if you want to turn that into a fraction, is the same thing as 20 over 100. And since we want to always reduce to lowest terms, 20 over 100, we can reduce to 1 over 5 by dividing both the top and the bottom numbers by 20. Our friend Sean is working with a section of the Yellowhead Highway. He calculates that the road drops 4 meters for every 36 meters of horizontal distance. What is the slope of the road? So what I'm going to do first is I'm going to figure out what our rise and run is. So since it drops 4 meters, it's going to be our rise. And for every 36 meters of horizontal distance means that this will be my run. So slope is equal to rise over run. So this will give me 4 over 36. And I can simplify this or reduce it to 1 over 9 as my slope. Now it says that warning signs are usually placed in areas where the grade is 6% or greater. Should Sean install a warning sign for the stretch of highway in Part E? If so, what grade should the sign show? If I plug in 1/9 on my calculator, I end up getting an answer of 0.1 repeating. So 0.1 repeating is the same thing as about 11.1%, because now I've multiplied this by 100 to give me 11.1%. We know that 11.1% is greater, and maybe I'll write that a little bit neater. 11.1% is greater than 6%. So yes, he should install a sign with a grade of, and this will hopefully spark some conversations, a grade of 12%. Why would we use 12% and not 11%? We can think about the rare case where someone has planned extensively for 11%, but that 0.1% is actually quite dangerous. It's much better for us to overstate the decline than understate it. And hopefully that will give you a sense of how engineers usually plan for things such as a higher weight limit than is actually stated. So another place where we can see slope being used is in roofing, where the slope of a roof is called the pitch. So this will be a cool use of slope for us. So the slope of a roof is what we call the pitch. So we express this as the number of inches of rise for every 12 inches of run. So for example, a roof that rises 6 inches every 12 inches of run is known as a 6/12 roof. So just note the pronunciation there. It's measured by placing a level on the roof, marking off 12 feet, or 12 inches rather, and then you measure the vertical distance between that mark and the roof below. So maybe just using one of these as a really quick example, what they mean by that is we can place a 12-foot or 12-inch measure here, and we measure the vertical distance that it goes down, and then we can figure out what that ratio is going to be. So we can use these triangles here to help us figure out what the roof pitch of each one could be. And just note that we're going to make sure that we're looking at every 12 inches of run. So first of all, we're going to look at the rise and the run. So in example A, you can see pretty quickly that the rise is 1. And your run, in this case, we're going to go 1, 2, 3, 4. You have a run of 4. So if we're calculating our slope, we can say that slope is equal to rise over run. And this will be the same thing as 1/4. So since we're looking at a pitch, we want to make sure that we're expressing this as a denominator of 12. So how do we do that? We're going to take the 1/4. We're going to multiply both the top and the bottom number by 3. So this will actually give us 3/12. So if we look back at our example, if we have a roof with a rise of 6 for every 12 inches of run, we call that a 6/12 roof. Well, here our rise would be 3 and our run is 12. So we can express this as a 3/12 roof. We can do the same thing with answer, or roof B rather. So we're going to look first at the rise. So we're rising up 5 units. So the rise is 5. Look at the run, 1, 2, 3, 4, 5, 6. Your run is 6. So once again, M is equal to rise over run. And we end up getting a slope of 5/6. But we want to make sure this denominator is 12. So we're going to multiply both the top and the bottom by 2. So we end up getting 10/12. So those are equivalent fractions. So we can convert that 10/12 or 10 over 12 to a 10/12 pitch. Last but not least, for question C, once again, we take a look at the rise. So the rise in this case is 4, and the run is 3. So we can look at the slope as rise over run, and that's going to be equal to 4 over 3. We're going to convert the 4 over 3 to a fraction with the denominator of 12. So we're going to multiply both the top and the bottom by 4. So this will give me 16 over 12. And if we turn this into a pitch, we get 16/12. Next, we're going to talk about the relationship between the angle of elevation and the slope. So they are directly related to each other. So remember from trigonometry that the angle of elevation is going to be your angle that is measured up from a horizontal line. So if you look at our example here, we can see that our angle of elevation, we are measuring up from this horizontal line. We're going to have to use the tangent ratio to help us figure out what that angle of elevation is going to be. Remember that your opposite side, and we can look at this triangle here, your opposite side is directly across from your reference angle, that little theta there in the corner, and your adjacent side is going to be the side next to the reference angle that's not the hypotenuse. So maybe for reference here, we know that this is the hypotenuse because it is directly across from the right angle. We're also going to need to use the inverse tangent function, which is going to look like this on your calculator, and that's going to help us find an angle when we know the tangent ratio. So a quick little recap here of using the tangent ratio. We are going to, first of all, label our sides. We know our reference angle is angle A. Oops, maybe I'll use a slightly better color. So we know that's angle A, which means that this will be my opposite side and this is my adjacent side. So I have tangent of angle A is equal to the opposite side over the adjacent side. So tangent of A is equal to 17 over 8. I'm just plugging in the numbers that I know. We need to take the inverse tangent of both sides. So when I do that, I'm actually getting rid of the tangent on the left-hand side, and I'm taking the inverse tangent of whatever I have on the right-hand side. So on your calculator, when you punch in shift or second tan, and then 17 divided by 8, we end up with 64.79, and since we are being asked to round to the nearest degree, we have A, or angle A, is equal to 65 degrees. For question B, we're going to start by labeling your reference angle. We know that this is the opposite side, and this will be my adjacent side. So tangent of angle A is once again equal to opposite over the adjacent side. So tangent of A is equal to 9 over 25. We're going to take the inverse tangent of both sides, and we'll end up with the inverse tangent of 9 over 25 is going to give us our measure of angle A. So once again, on your calculator, we're going to punch in the inverse tangent of 9 over 25, and we end up with roughly 19.79, which is 20 degrees once we've rounded it to the nearest whole number. Last but not least on this page, we're going to take a look at example C. So you know that angle A is up here, which means that the 59 will be my opposite side, and the 68 is my adjacent side. So again, starting off with the tangent ratio, tangent of A is equal to the opposite side over the adjacent side. We can fill in what we know. Tangent of A is equal to 59 over 68. Then we're going to take the inverse tangent of both sides, and once I put in the second, or rather inverse tangent of 58 or 59 over 68, I'll end up with 40.94, which rounds up to 41 degrees. Let's apply the angle of elevation to some problems in context. So what angle does a ramp with a slope of 1 to 8 make with the ground? Express your answer to the nearest degree. So the first thing that we're going to notice is that because the slope is 1 to 8, we can actually express this as a fraction. 1 to 8 is the same thing as 1 over 8. If we turn this into a slope, we can understand that your rise is equal to 1 and your run is equal to 8. So if we were to craft a ramp, you would see, and of course this will be a little bit not to scale, we'll see that for a ramp that kind of looks like this, we're going to have a run of 8 and a rise of 1. So what we're trying to do is figure out what this angle here is. So that 1 will be my opposite side, and the 8 will be my adjacent side. So let's use that as angle A. So I can say the tangent of A is equal to my opposite side over my adjacent side. So tangent of A is equal to 1 over 8. I can take the inverse tangent of both sides, so the inverse tangent of 1 over 8. I'm going to put that into my calculator. So the inverse tangent of 1 over 8 ends up giving us 7.125. We're going to express that to the nearest degree, so angle A is equal to 7 degrees. In example number 2, it says that Yannick and Emily plan to build a wheelchair ramp for their grandmother. They learned that outdoor ramps must have a slope close to 1 to 12, but not greater. This ensures that the person in the wheelchair can safely travel up and down the ramp. So to start, they measure the space that they have to build the ramp. The distance from the doorway straight down to the ground is 2 feet. The walkway along the ground is 40 feet. Do Emily and Yannick have enough space for a ramp that meets the safety rule? So what we're going to have to do is figure out exactly what the slope of this ramp could be. If we take a look and we see that your distance from the doorway straight down to the ground is 2 feet. So anytime we talk about vertical distance, this will end up being our rise, which means that your walkway along the ground is 40 feet. That will be our run. So our slope is equal to rise over run. And we know that we have a rise of 2 feet over 40. So I've got a slope of 1 over 20. So 1 over 20 is what we're looking at. And just to get some work done ahead of time, we can convert 1 over 20 to a decimal. And we know that 1 over 20 is equal to 0.05. What we're going to do is we need to compare this to the slope of 1 over 12. If we compare that, and we know that 1 over 12, and we put that into our calculator, 1 over 12 is actually equal to 0.08. So 1 over 12 is equal to 0.08. So since 0.05 is less than 0.08, then yes, they have enough space for a safe ramp. So they have enough space for a safe ramp. So when they build this ramp, what angle will that ramp make with the ground? Again, if we take a look at a picture that we could draw, we know that straight up and down, a vertical distance of 2 feet, and a horizontal distance of 40 feet. We're going to once again measure angle A here. We know that this will be my opposite side. This will be my adjacent side. So tangent of angle A is equal to the opposite side over the adjacent side. So tangent of A is equal to 2 over 40. I'm going to take the inverse tangent of both sides here. So I have A is equal to the inverse tangent of 2 over 40. And when I put the inverse tangent of 2 over 40 into my calculator, I end up with about 2.86, which rounds to 3 degrees. So 3 degrees will be the angle that the ramp makes with the ground. Now, slope can be thought of as something called a rate of change, which just describes the change in one variable over the change in the other variable. So essentially what we're doing is we're comparing one variable to another. There's actually a whole bunch of different examples that we see every day, such as speed, where we compare kilometers to hours, or we can see the price of maybe chicken or turkey or beef at the grocery store, usually in dollars per pound or dollars per kilogram. There's lots of other examples out there as well. Maybe take about 30 seconds to try to think of them on your own. Pause the video, and then unpause once you're ready to continue. So some examples that we can also list, we can think of precipitation or snowfall. And usually we can think of it as maybe millimeters or centimeters per hour. We can also think of gas consumption in a car. Typically when you go shopping for a car, you want to look for the lowest miles, or the highest miles per gallon rather. Oops, MPGs. So miles per gallon, or in Canada, we use liters per 100 kilometers, which really just means we're trying to look for the lowest liters per 100 kilometers. Because let's say, for example, 5 liters that you use up to drive to drive 100 kilometers, or you can use 10 liters, which would obviously be a little bit more. One last example that we can use is maybe a population change. So for example, we look at the number of people that are born per year, maybe something like a birth rate is also another example of a rate of change. So let's take a look at a contextual problem. A carpenter makes cabinets for a construction company and must meet a daily quota or goal. The manager checks his inventory after 4 days and finds that there are 56 cabinets. After 9 days, the same carpenter has made 126 cabinets. So what is the carpenter's daily quota or goal in terms of the number of cabinets that needs to be made per day? Well, there's a couple ways that we can do this. If we see here, the first set of cabinets, he has made 56 cabinets in 4 days. So we can take a look at 56 cabinets over 4 days. If we were to divide this out, 56 divided by 4, we would end up with 14. Now, because we've been looking at slope, let's just go ahead and keep this as 14 over 1, because we know that 14 is the same thing as 14 over 1, but we're going to also keep our variables here. So this means that we have 14 cabinets per 1 day. Now what we're going to do is we're going to compare this to when he has made 126 cabinets over 9 days. So 126 cabinets over 9 days. If we were to actually divide these two out, once again, we'd end up with 14 over 1, or 14, and we can state that this is 14 cabinets per 1 day. So it seems like this carpenter is very consistent with the number of cabinets that he makes. So we can state that the carpenter's daily quota is 14 cabinets per day. And again, it does look like a slope, but really in this case, we're referring to it as a rate of change because we are definitely comparing one variable, or the change in one variable, compared to the change in another variable. In this next example, we are taking a look at the distance that Yvonne has cycled on her cycling trip along the Trans-Canada Trail in Manitoba. She decided to plot the data on a grid, and we need to first find out the slope of the line through those points. So what we can do is we can take a look at any of the 2 points here. Again, I can pick this one and this one. I can choose this one and this one, or I could choose the first one here and the last one. It doesn't really matter. Typically, what I suggest to students is to choose the points with the lowest numbers. That way they'll be a little bit easier to work with. So what I'm going to do first is I'm going to figure out the rise and the run between the first 2 points here. So I'm going to go ahead and count up my units, but we notice here that we start at 24 and we make our way until 48. And we can see here that each square is not actually just 1. Each square adds 6. So we go from 24 to 30 to 36 to 42 to 48. So your rise in this case is 24. And then we're going to look at the run, and we can see here along the scale at the bottom, each square is actually worth 0.5. So when we go across 2 squares, we're actually only just moving 1 hour. So our run is just 1. So we can go ahead and calculate the slope. We can say that slope is equal to rise over run, which is just equal to 24 over 1. Now, what does the slope represent in this case? This is just essentially her distance traveled per hour. And we can see that when we're using our rise over run, our variables, right, we are looking at 24 kilometers per or over 1 hour. So this is her distance traveled per hour. Some people might interpret this as the speed. It's really hard to say that if she's going to travel at a constant rate. She might have, she might not have. We're just going to take this as her distance traveled per hour, which is really just 24 kilometers per 1 hour. So for this next part here, we're going to go and use our proportions to help us figure out how far Yvonne traveled in 1 3/4 hours. The first thing that we're going to do is convert this into a decimal. So I'm going to convert that into 1.75 because it's going to be a little bit easier to work with rather than a mixed fraction. So we're going to set up our proportion in this way. We know that she travels 24 kilometers per 1 hour. So this should be proportional to her traveling x kilometers per 1.75 kilometers, or 1.75 hours rather. To solve this proportion, I'm going to go ahead and I'm going to just multiply the 1.75 up with the 24. You can cross multiply the 1 and the x, but really we don't need to, because once we do this, we have already isolated for x, and whenever you multiply something by 1, nothing changes. We will end up with x is equal to 42, or in this case, 42 kilometers. So she travels 42 kilometers in 1 3/4 hours. For this next part here, we're trying to figure out the time it took Yvonne to travel 55 kilometers. So again, we're going to set up a proportion using our slope. So 24 kilometers per 1 hour has to be equal to 55 kilometers per x hours. So once again, we can cross multiply here, and we notice that x is on the bottom, so we're going to cross multiply onto both sides. 24 times x gives you 24x, and 1 times 55 gives you 55. Now we have 24x is equal to 55. All we need to do now is divide both sides by 24, and we'll get rid of the 24s on that side. And we'll finally end up with x is equal to 55 over 24. And if we turn this into a decimal, we get about roughly 2.3. So roughly 2.3 hours, which is a little under 2 hours and 20 minutes. It's a little under a third. So roughly Yvonne took around 2 hours and 17 minutes, we'll guess, without using our calculator. So 2 hours and 17 minutes is how long it has taken Yvonne to travel 55 kilometers. So on this page, I'd recommend that you guys go ahead and try it out first, pause the video, and then unpause once you're finished to see the solution. So Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted the data on a grid. What is the slope of the line through these points? So once again, all I'm going to do is figure out the rise and the run here. So we're moving from 24 to 48. That is 24 units that we moved up, or rather $24. So the rise is 24. And then we can see as we go from this line to this line, we're actually moving across 2. So our run is going to be 2. So our slope, m is equal to rise over run, is equal to 24 over 2. And then we can simplify this to 12 over 1. Now what does the slope represent? Well, in this case, it's going to be his pay per 1 hour. So this is his, we can state that it's his hourly wage of $12 per hour. And we can see here, if we're looking at the variables, this is $12 per 1 hour because we're looking at the y, or the change in y over the change in your x. Now, how can the answer to part B be used to determine how much he earned in 3.5 hours and the time it took for him to earn $30? So again, just like the previous example with Yvonne, we are going to set up a couple of proportions to help us figure this out. So I'm giving myself a little bit of space here. So since I know that his hourly pay is $12 per 1 hour, we're trying to figure out how much he has earned per 3.5 hours. And maybe I'll note, where did I get the 3.5? 3.5 is the same thing as 3.5. So we're going to cross, or we don't really need to cross multiply here. Let's go ahead and multiply that by 3.5. So we have 12 times 3.5 is equal to x. And it just so happens that x is also equal to 42. So it does seem like 42 is the answer to everything. So $42. So Tom has earned $42 in 3.5 hours. Next, we're going to figure out how long it took Tom to earn $30. Now let's figure out how long it took for Tom to earn $30. So what we can do is we're going to go ahead and set up our proportion. $12 per 1 hour is equal to $30 per x hours. We can cross multiply and we'll get 12 times x gives you 12x, and 1 times 30 is just 30. I'm going to divide both sides here by 12. So I divide by 12, divide by 12, and I get x. Once I come over here, x is equal to 2.5. So it took Tom 2.5 hours to earn $30. Now the last question that we're going to look at today is we are seeing a mechanic tracking the amount of gas leaking from his car using this graph. So what is the rate of change? Luckily for us, there are 2 points that we can use to figure out what our rise and run will be. So our first step, let's go ahead and figure out the rise. So in this case, we are moving from a positive 3 here up until 6. So that's a difference of 3. So our rise is a positive 3. And then moving across from here to here, we are moving from 4 to 8. So our run is equal to 4. We can write our slope is equal to rise over run, and we'll fill in our numbers. We have 3 over 4. Now there's a couple of different ways to approach this question. Since we know that we're looking at time on the bottom and amount in gallons on the top, as it stands, we have 3 gallons per 4 minutes. Now, typically, when we track things in terms of minutes, we don't say every 4 minutes something happens. Typically, we say everything happens per 1 minute. So how do we convert this? Well, if we look at this in terms of a decimal, 3/4 is the same thing as 0.75. And we can actually express this as 0.75 gallons per 1 minute. So we can state that the rate of change is 0.75 gallons per 1 minute, which is how much the tank is leaking every 1 minute, 0.75 gallons per 1 minute. Anyways, that's it for today's lesson. Hopefully you guys enjoyed everything. Let me know if you have any questions in the comments below. I'll see you in the next video.